Welcome, dear listener. Tonight, as you prepare to let go of the noise and activity of the day, I invite you into a quiet journey. This is not a lecture in the usual sense, where information is rushed and crowded. This is a slow unfolding of knowledge, designed for peace, designed for rest, and yet still offering the gift of understanding. You are here to listen, to drift, to breathe, and to sleep. As you relax, the story of the periodic table will gently accompany you. It is a story of order, of hidden pattern. The table itself may appear at first as a chart of boxes and numbers, letters and symbols, something rigid and scientific. But tonight you will hear it in another way. The periodic table is a storybook, one written in the language of the universe. Each element is a character, each column a family, each row a journey forward in time. This is not a task to memorize, nor a challenge to test your memory. Instead, it is an invitation to drift through a quiet museum of existence, where each exhibit is explained. The voice you hear is not meant to push, but to guide. Imagine standing at the shore of a calm sea. The waves move in and out, steady and rhythmic. The information you hear tonight will be like those waves, arriving gently, retreating gently, carrying you further into rest. You do not need to grasp at them, you do not need to hold tightly. If a fact passes by, it will return again in another form, and in that rhythm your mind will find both calmness and learning. The periodic table is built on the idea of patterns. Atoms are arranged not randomly, but with purpose. The smallest, hydrogen, begins the journey. Helium follows, simple yet complete. Step by step, complexity increases, and order reveals itself. To know this chart is to glimpse the design of matter, the quiet architecture beneath everything. And as you hear about it, your mind can rest in the reassurance that the universe is not chaos, but structure. Even as your own thoughts quiet down for the night, take a breath in. Let it fill you slowly. Exhale, and release the weight of the day. In this rhythm you are safe, and in this rhythm the words will come. Tonight you may drift in and out of attention. That is natural. At times, you may hear each word clearly. At other times, the voice may fade into the background, no different than the sound of rain, no different than a soft breeze through leaves. Both experiences are perfect. The mind learns in layers, and even in dreams it continues to weave patterns. The table is not only science, it is poetry. Consider its beauty, rows like stanzas, columns like verses, each part connected, each line building upon the last. Hydrogen and helium are the opening lines, small yet profound. Oxygen and carbon are the verses of life itself. Gold and silver shine like the metaphors of history. Uranium and beyond carry the heavy tones of power and mystery. Just as a poem is not only words but also rhythm, the table is not only elements but also music. You are here to listen to. In this introduction, let us acknowledge the patience of the scientists who discovered these truths. They did not rush. They spent nights in dim laboratories, watching reactions, writing notes, following faint trails of logic. Their work required focus and quiet determination. And now, centuries later, you benefit from their patience. Their discoveries are shared with you gently, without demand, without urgency. In this way, the story of science becomes the story of calm, the story of slow, steady effort. The periodic table is everywhere around you, even now. It is in the air you breathe, the oxygen flowing to your lungs, the nitrogen filling the atmosphere, the carbon within every living cell. It is in the calcium of your bones, the iron in your blood, the sodium and potassium that allow your nerves to carry gentle signals. It is in the copper wires that bring light, the silicon that powers your devices, the helium that fills balloons, the gold that shines in rings. To learn about the table is to learn And so, tonight, as this lecture begins, imagine the table not as something far away, but as a companion. Imagine its squares as lanterns, each one glowing softly. Row by row, they stretch out before you like stepping stones across a river of time. You do not need to cross them quickly. You may pause at each one, or drift past them, or let them pass by you. There is no race. There is only rhythm, only order, only calm. Rest now in the knowledge that science is not separate from peace. Knowledge can be gentle. understanding can be soothing. You are safe, you are calm, and the periodic table is here, waiting like a quiet guide. Tonight, learning will meet rest, and both will carry you gently into the night. Long before Earth formed, before oceans, mountains, or even the quiet breath you take now, there was only darkness, silence, and then a great unfolding of light. In the earliest moments of the universe, nearly 14 billion years ago, matter itself began to emerge. The first elements were born in that moment of creation, when the universe expanded in a brilliant event we call the Big Bang. Out of that explosion, hydrogen appeared as the simplest and most abundant element, and helium soon followed. Imagine this moment, not as a violent explosion but as a slow blossoming of existence, like a flower unfurling its petals across infinite space. With each passing second, the universe cooled, and these first building blocks began to gather. The elements drifted, spread, and collected into great clouds of gas. Over time, gravity, that silent and patient force, drew them together. Clouds thickened, swirled, and collapsed into the first stars. In their glowing hearts, something new began to happen: fusion. The origins of the elements are also the origins of complexity. Hydrogen, simple as a single proton, was the seed. Helium, with its calm stability, was its first companion. But stars, burning and collapsing, did not stop there. They were factories of transformation. Deep inside, at temperatures beyond imagination, atoms collided and fused, forming carbon, oxygen, nitrogen, and other heavier elements. This process, called stellar nucleosynthesis, became the great alchemy of the universe. Stars were not just. Consider carbon, the element that forms the basis of life, created in the hearts of ancient stars that lived long before our sun was born. When those stars reached the ends of their lives, some collapsed quietly, while others ended in great supernova explosions. In these cataclysmic events, heavier elements were forged. Iron was created in vast abundance, and beyond iron, even heavier elements, gold, uranium, lead, were cast out into space. These supernovae scattered the seeds of matter across the galaxy. As you lie here, breathing steadily, it is worth remembering that your body is built from these ancient gifts. The calcium in your bones, the oxygen in your blood, the phosphorus in your DNA, all of them were formed billions of years ago in stars that no longer exist. The phrase often whispered by scientists is true: we are made of star stuff. Every cell, every heartbeat, carries within it the history of the cosmos. To learn about the periodic table is not only to learn about atoms, but to discover the S. The story of the elements is a story of contrasts. On one side, there is fire, heat, and destruction, the collapsing star, the violent supernova, the immense forces that crush atoms together. On the other side, there is calm continuity, the quiet orbit of planets, the gentle rise and fall of life, the way elements rest now in your body without chaos, simply performing their roles in silence. Out of cosmic violence came personal peace. Out of great explosions came the possibility of breath, thought, and S. Picture the early universe again. Clouds of hydrogen and helium floating in silence. Slowly, through billions of years, stars form, burn, and die, scattering their gifts. Galaxies swirl into being, clusters form, and eventually, our own solar system emerges. The Earth coalesces from dust and rock, infused with elements made in those distant stars. Water gathers, life stirs, and eventually, we arrive here, listening, resting, and learning. The long journey of the elements becomes the quiet background to th. Hydrogen remains the simplest, yet it is the most abundant. Nearly 3/4 of the visible universe is hydrogen. Every star begins with it, every galaxy is built from it. Helium follows, less abundant but essential, filling the interiors of stars, filling balloons on Earth, drifting silently upward into space. Then come the heavier elements, each rarer, each formed through patient processes of fusion and death. Oxygen, third most abundant, fills your lungs. Carbon forms the skeleton of life. Ing. The periodic table is not random because the universe itself is not random. Atoms follow rules. They fit into patterns. Protons and neutrons gather in nuclei, electrons dance in shells, Energy is shared and released according to order. When you look at the table, you are looking at the frozen memory of these cosmic processes. Each square is not only a fact of chemistry, but a story of birth. Each element is a time capsule, carrying within it the trace of an ancient star, the whisper of a universe always. This calm reflection brings us to an important realization: the table is not only human discovery, but also human connection. Our ancestors did not know about protons or electrons, yet they wondered at the stars, felt the warmth of fire, breathed the air, drank the water, and lived through the presence of elements. It took centuries of observation and thought before patterns were uncovered, but the origins of the elements were always there, waiting. Tonight, as you let your body sink deeper into rest, learning about the origins of the elements is to see both extremes: infinite time and immediate presence, vast space and personal closeness, violent beginnings and quiet continuations. As you drift, let this contrast soothe you. The universe has already performed the difficult work. You are simply here to receive its story. The table you will explore is not the start of the story but the continuation. It is the record of everything that came before, simplified and ordered into squares. And as you fall so breathe again, slowly, evenly, as the story continues. The origins of the elements are the origins of you, and in learning them, you are not only gaining knowledge, you are returning to a truth older than Earth itself. From the fire of stars to the quiet of your bed tonight, the journey flows without interruption. And now, with calm anticipation, we move gently forward, ready to see how humankind began to place these ancient gifts into order, arranging them into the chart we now know as the periodic T. Long before the periodic table became the neat chart we see in classrooms today, the natural world presented itself as a puzzle. People in every culture noticed substances that behaved differently, some shining, some dull, some soft, some unyielding. Ancient civilizations worked with gold, silver, copper, and iron without fully understanding what they were. They melted them, shaped them, admired their colors and strengths. Yet they had no chart, no clear map, only experience and curiosity. Slowly, across. As centuries passed, alchemists tried to make sense of matter. They believed that metals could be transformed into one another, that base materials could be turned into gold. Their efforts were often shrouded in secrecy and mystery, yet in their experiments they gathered fragments of real knowledge. They discovered reactions, noted properties, and stumbled toward chemistry. Out of their dreams of transformation, real transformation occurred, not of metals into gold, but of alchemy into science. It was by the 18th century, progress accelerated. Scientists like Antoine Lavoisier began listing substances carefully, giving names, identifying what was truly elemental and what was not. Oxygen, nitrogen, and hydrogen were classified. The air itself was revealed to be a mixture, not a single substance. Water was no longer seen as a basic element but as a compound of hydrogen and oxygen. Confusion began to give way to clarity. Yet still, these discoveries stood like scattered pieces of a puzzle, lying on. Imagine trying to organize dozens of unfamiliar cards on a table. Some belong together, others seem unrelated. That was the state of chemistry in the early 19th century. More and more elements were being discovered: sodium, potassium, calcium, chlorine, but there was no system. Scientists created lists, tables, and groupings, but they lacked the unifying pattern. Some arranged by weight, some by properties, some by both. Patterns flickered into view, then slipped away again. The dream of order was close. It was Dmitry Mendeleev, a Russian chemist in the mid-19th century, who gave the dream shape. Working in the 1860s, he faced the same puzzle but with determination and patience. He wrote the names of the known elements on cards, adding their weights and properties. He shuffled them, arranged them, tested different sequences. Slowly, patterns emerged. He saw that certain properties repeated regularly, that families of elements behaved alike. He realized that when placed in rows and columns, the boldness of Mendeleev's vision lay not only in what he arranged, but in what he left open. There were gaps, empty spaces in his table where no element was yet known. Rather than forcing the puzzle closed, he allowed the spaces to remain, predicting that one day new discoveries would fill them. This courage, trusting the pattern enough to leave it unfinished, was extraordinary. Later, those predicted elements, like gallium and germanium, were indeed discovered, and they fit perfectly into the table. This moment in history reflects a beautiful contrast. Before Mendeleev, there was confusion, scattered facts, lists without pattern, knowledge without structure. After Mendeleev, there was clarity, a framework, a chart, a guiding light for chemistry. What had been a jumble of information became a harmonious picture. In the same way, tonight, scattered thoughts may feel like fragments. Yet as you listen, as you rest, they too can find order. Calm arises when the mind allows patterns to emerge naturally. The table was not only a scientific tool, it was a bridge. It connected the known to the unknown, the discovered to the undiscovered. It guided experiments, allowing chemists to predict what they might find and where. For students, it became a way to see the universe in a single image. For teachers, it was a language, a map to explain the invisible world of atoms. And for all of us, it became a reminder that nature hides structure even in apparent chaos. This structure does not need to be forced, it reveals. Picture Mendeleev himself, a man with ink-stained fingers, surrounded by notes and cards, shifting them late into the night. Imagine his concentration, his quiet persistence. Outside, winter winds howled across St. Petersburg, but inside his study, a new order was being born. The quiet shuffle of paper, the scratch of a pen, the soft glow of lamplight, these small sounds accompanied the birth of the table we know today. From that quiet work, the great chart emerged, and with it, a new way of seeing matter. Since that time, the table has grown. New elements have been discovered, heavier ones synthesized in laboratories, yet the pattern remains. The structure Mendeleev saw has endured. The table has become not only a tool but a symbol of patience, of human curiosity, of the beauty of order. It shows us that even in complexity there is simplicity, that even in the many there is unity. For learners, it offers reassurance. Knowledge can be organized, mysteries can be understood, the world has a rhythm, and we. And so, as you rest tonight, think of the birth of the periodic table as a story of clarity emerging from confusion, of light emerging from shadows. The elements, once scattered, were given a home. Your thoughts, once restless, can also find a place of rest. The table stands as both chart and metaphor, reminding us that patience uncovers order, and order brings peace. With this understanding, we are ready to move forward, gently, into the structure of the table itself, where every row and column carries I. When you look at the periodic table, you see a rectangle filled with boxes, symbols, and numbers. At first glance, it may appear like a simple chart, but beneath that chart lies an extraordinary order, a design shaped by the very laws of nature. Each row, each column, and each space has meaning. Tonight, we will slowly walk through the structure of the periodic table, not in haste but in a calm rhythm, so that you may drift peacefully while also grasping its quiet beauty. The table is not random, it is in. The table begins with rows called periods. There are 7 of them, stretching from left to right. Each period represents elements that grow in complexity as you move across. The first period contains only hydrogen and helium, the simplest of all. As you move to the second period, new possibilities unfold: lithium, beryllium, carbon, nitrogen, oxygen, fluorine, and neon. With each step, electrons are added, shells are filled, and properties shift. The rhythm is like steps on a staircase, gentle but sure. Within these periods lie vertical columns known as groups. Each group is like a family, sharing traits and tendencies. On the far left are the alkali metals, soft, reactive, eager to bond. Beside them, the alkaline earth metals, slightly calmer but still lively. In the center are the transition metals, strong and shining, the builders of bridges and tools. On the far right are the noble gases, silent and still, content in their stability. Each family carries its own personality, repeating across the table. The groups are numbered, sometimes from 1 to 18, sometimes with Roman numerals, but the idea is the same: elements in the same group act alike. Sodium, potassium, and lithium all fizz in water, releasing hydrogen. Neon, argon, and krypton all glow quietly in electric light. These similarities are not accidents. They arise from the structure of atoms, the arrangement of electrons in their outer shells. Atoms with similar outer shells behave alike, just as members of a family may share familiar feet. At the heart of the table is the concept of atomic number. Each element is defined not by weight, not by size, but by the number of protons in its nucleus. Hydrogen has 1, helium has 2, lithium has 3, and so on. The atomic number rises steadily as you move from left to right, from top to bottom. This simple count brings order to everything. It explains the repetition of properties, the cycles that give the table its periodic nature. As the numbers rise, properties change in rhythm, repeating them. Think of the table as a grand city. The rows are streets, running left to right. The columns are neighborhoods, stretching top to bottom. In each neighborhood, the families resemble one another. Some are lively and reactive, others calm and reserved. Some are builders, others dreamers, some dangerous, some life-giving. And yet all are part of the same city, connected by invisible patterns. To walk through this city is to learn its districts, its families, and its rhythms. Tonight, we walk gently, without. On the left side of the table are the metals, gleaming and conductive, ready to form bonds. On the right are the nonmetals, essential for life, fragile yet powerful. Between them lies the staircase of metalloids, bridging both worlds. Silicon, for instance, acts like a metal in some ways and a non-metal in others, becoming the foundation of modern technology. This contrast between left and right, between strong and subtle, between reactive and reserved, creates balance. Just as in life, opposites complement. At the bottom of the table, separated from the main body, lie the lanthanides and actinides. These two rows are often placed apart to keep the table compact, but they belong in specific slots. The lanthanides are known as rare earth elements, glowing softly in screens and magnets. The actinides, such as uranium and plutonium, carry immense energy, used in both power and destruction. Though they sit quietly beneath the main table, they are part of its design, hidden chapters of the larger story. Their plaque. Every placement, every box, is determined by quantum rules. Electrons fill shells and subshells in precise orders, shaping the properties of each atom. The table is not only chemical but quantum, a reflection of the invisible mathematics that governs matter. You do not need to master the equations tonight. Simply know that the order exists, steady and elegant, flowing like music beneath the surface. Each element is a note, each group a chord, each period a phrase, and the whole table a symphony. To list. As you drift, you may picture the table itself. Perhaps you imagine it as a glowing grid, each box lit softly in the dark. Hydrogen begins at the top left, a gentle spark. Helium shines alone at the top right, glowing like a small star. Then the grid expands downward and outward, rows filling, columns stretching, until the entire chart glows before you like a constellation of knowledge. Each element is both unique and part of the whole. Each has its place, just as each star has its place in the night sky. The beauty of the table lies not only in its design but in its flexibility. When new elements were discovered, they found their homes within the pattern. When scientists probed deeper, synthesizing elements heavier than uranium, those too found their spaces, extending the table beyond nature into the realm of creation. Yet the order held. Even at the edges of knowledge, the pattern remained true. This stability is a source of comfort. It shows that nature, though vast, is not random. Even in the unknown. In your mind, let the rows and columns blur into calm lines. Think of the rhythm. Reactive on the left, noble on the right, builders in the middle, secrets at the bottom. The entire chart becomes a landscape, balanced and whole. To rest with this knowledge is to know that the universe itself carries patterns, and that you, too, are part of them. Your breath follows rhythm, your heartbeat follows rhythm, your thoughts follow rhythm, just as the table follows rhythm. In this way, the structure of the period. So let yourself drift with this order. The table is a map, but also a lullaby, its cycles repeating softly, its families singing in harmony. As you sink deeper into rest, the structure holds you, steady and patient. Every row and every column has a place, and so do you. And with this sense of order, we are ready to step into the journey of the elements themselves, beginning with hydrogen and helium, the cosmic duo at the foundation of it all. Hydrogen, the simplest and most abundant element in the universe, begins our journey. It is the first note in the symphony of matter, a quiet presence yet unimaginably vast in importance. One proton, one electron, nothing more. And yet, from this simplicity comes stars, galaxies, and life itself. Nearly 3/4 of the visible universe is hydrogen, drifting silently through space, gathering into clouds, collapsing into stars, igniting into light. When you breathe, when you think, when you dream, you imagine a universe filled only with hydrogen. After the Big Bang, it floated in endless clouds, light and pure. Over time, gravity drew these clouds together, forming the first stars. Inside those stars, hydrogen atoms fused, combining to create helium. This process, nuclear fusion, released energy, and the stars began to shine. In this way, hydrogen is the origin not only of matter but of light itself. The starlight that fills the night sky, the warmth that nurtures planets, all begins with hydrogen. On Earth, hydrogen is both familiar and elusive. As a gas, it is colorless, odorless, and so light that it slips away from our atmosphere into space. We rarely encounter it directly in daily life, yet it is everywhere. Water, the essential substance for life, is 2 parts hydrogen and 1 part oxygen. The food you eat, the energy stored in your body, the fuels that power technology, all rely on hydrogen bonds, quiet connections that hold molecules together. In this way, hydrogen is both invisible and present. There is a contrast in hydrogen's nature. On one hand, it is gentle, forming water and nourishing life. On the other, it is volatile, capable of fueling explosions and fires. It is the lightest of gases, floating upward, but also the fuel of stars, burning with unimaginable intensity. To hold both these truths in mind is to see hydrogen's dual role, calm in daily life, powerful in the cosmos. As you rest tonight, imagine hydrogen as a drifting companion, rising softly like a balloon into the sky, yet also. Now we come to helium, the second element, formed when hydrogen atoms fuse under the crushing heat of stars. Helium is simple too: 2 protons, 2 neutrons, 2 electrons. It is stable, content, unwilling to react with other elements. While hydrogen begins the story, helium offers balance, a kind of calmness in the fabric of matter. Helium is found in stars, filling them with energy, but on Earth it has its own quiet roles. It cools scientific instruments to near absolute zero, it fills balloons with lig. Helium's behavior is remarkable. Unlike most elements, it resists bonding with others. It floats gently, slipping upward, disappearing into the sky. It does not burn, it does not corrode, it simply exists, silent and serene. In this way, helium is like the breath of peace in the periodic table. To think of helium is to imagine stillness, the quiet glow of neon lights, the calm rising of a balloon at a celebration. Even its voice, when inhaled, becomes light and playful, reminding us of the softness it ca. Together, hydrogen and helium form a cosmic duo. They make up almost all of the visible matter in the universe, simple yet foundational. Hydrogen fuels the stars, helium is the product, the quiet evidence of fusion at work. Every heavier element arises from their union. Without them, there would be no carbon, no oxygen, no iron, no gold. To learn about them is to begin at the source, the root of the story, where simplicity births complexity. They are the opening chapter of the periodic table, and they show. Think for a moment of the sun. It is a vast sphere of hydrogen, burning steadily for billions of years, fusing atom after atom into helium. This steady process releases light and warmth, bathing the Earth in energy. Every tree that grows, every wave that moves, every life that stirs depends on this quiet transformation. Hydrogen becomes helium, helium glows, and life continues. As you lie in rest, you too are bathed in this light, warmed by a process that began with the simplest atoms in the universe. Teach. Hydrogen and helium also carry cultural meaning. For centuries, fire and air were thought to be basic elements of the world. In truth, what humans called fire was fueled by hydrogen, and what they called air was filled with nitrogen and oxygen, yet touched by helium's presence. Balloons floating upward, stars glowing in the sky, flames dancing, all trace back to these first two elements. They are not only scientific facts but symbols of beginnings, of movement, of lightness. Hydrogen rises, helium floats. There is harmony in their relationship. Hydrogen, restless and reactive, eager to combine and transform. Helium, calm and complete, refusing to change. Together they embody the balance of energy and stillness, of creation and rest. Hydrogen is the spark, helium the glow. Hydrogen reaches outward, helium settles inward. In this contrast lies a lesson: energy must be balanced by calm, action must be balanced by rest, motion must be balanced by stillness. As you drift deeper into sleep, you too carry this B. In laboratories, hydrogen is studied as a fuel of the future, promising clean energy through fuel cells. Helium is studied for its ability to cool, to stabilize, to preserve. In science, as in life, their roles continue. Yet beyond their practical uses, their presence reminds us of our connection to the stars. Every atom of hydrogen in your body, every breath of oxygen you take, began in cosmic clouds shaped by these first two elements. You are, in a very real sense, the universe becoming aware of itself. So tonight, as you let your body grow heavy and your mind quiet, remember that everything begins with hydrogen and helium. They are the foundation, the first chapter of the periodic table, the cosmic duo whose partnership built the universe. Hydrogen, the restless spark. Helium, the gentle glow. Together they create stars, light, warmth, and the possibility of life. Together they remind us that even in simplicity, there is wonder. And as we leave this section, we prepare to meet the next family of element. The next family we encounter on the periodic table are the alkali metals, a group of elements that sit in the very first column, far to the left. They are lithium, sodium, potassium, rubidium, cesium, and francium. Though they appear small and unassuming in their little boxes, they are among the most reactive elements known. Their personalities are fiery, their responses swift. And yet, as you listen to their story tonight, the speed of their reactions will be told slowly, calmly, so that even the most Lithium comes first, the lightest of the group. Its name comes from the Greek word for stone, yet it is one of the softest metals you could imagine, so soft that it can be cut with a knife. Lithium is used in batteries, quietly powering devices around you, storing energy with patience. In the human body, lithium salts have been used to stabilize moods, offering calm in the storm of emotions. Here is the contrast: a metal that in water reacts violently, yet in the mind brings balance and stillness. Next is sodium, familiar to nearly everyone. You may know it as part of ordinary table salt, sodium chloride. Salt flavors our food, preserves it, and carries significance in every culture across time. Yet sodium by itself is nothing like the quiet crystal of salt. Pure sodium is a silvery metal that bursts into flame when touched with water, releasing hydrogen gas with a hiss and spark. It is fiery, dramatic, and dangerous in isolation. But in partnership, combined with chlorine, it becomes a life sustain. Potassium follows, another metal essential to life. In your body, potassium ions flow in and out of cells, allowing nerves to send signals, allowing muscles to contract, including the steady rhythm of your heart. Without potassium, life would falter. Yet pure potassium too is restless, bursting into flame in water. Once again, we see the duality of nature, volatile in one context, vital in another. As you drift deeper into rest, think of potassium as both spark and pulse, fiery in the lab, but gentle in why. After potassium, the alkali metals grow heavier: rubidium, cesium, and francium. Rubidium glows with a reddish flame, a color that betrays its name, which comes from the Latin word for deep red. Cesium, pale and golden, is one of the most reactive metals of all, melting near room temperature, almost liquid in its eagerness to react. Francium, the rarest and most unstable of the group, exists only in fleeting traces, vanishing as soon as it appears. Few people have ever seen it, yet it completes the family. What binds this group together is not only their fiery personalities but their shared structure. Each alkali metal has just one electron in its outermost shell. That single electron is held loosely, eager to be given away. This is why they react so quickly, so dramatically. The smaller the atom, the more tightly the electron clings. Lithium holds on modestly, sodium less so, potassium even less. As the atoms grow larger down the column, the outer electron sits farther from the nucleus, more easily lost. In the periodic table, the alkali metals are placed at the far left, the beginning of each row after hydrogen. Their presence there is no accident. They represent beginnings, the first step in each period, a fresh cycle of properties repeating. Each one sets the tone for the row, just as a dawn sets the tone for the day. Their placement reminds us of renewal, of cycles starting anew, of the rhythm in nature and knowledge. They are volatile, yes, but they are also symbols of energy at the start of a path. Despite their volatility, the alkali metals bring remarkable benefits. Sodium and potassium keep the body alive. Lithium offers stability in medicine. Cesium is used in atomic clocks, measuring time with incredible precision, so that the ticking of the universe can be tracked. Rubidium and cesium help in electronics, guiding signals across circuits. Even the rarest, francium, though not practically used, carries meaning as a reminder that the table includes both the abundant and the fleeting, the seen and. To imagine their reactivity, picture a calm bowl of water. Drop in a piece of sodium, and instantly the water sizzles, bubbles, and bursts into flame. The reaction is dramatic, but here, in this lecture, it is told as softly as a bedtime story. Imagine the spark not as chaos, but as a small firework in the distance, brief and bright, before fading into the night. That is how the alkali metals behave, too restless to sit still, always eager to give, always releasing their energy quickly and brightly. Yet these metals remind us that energy and peace are not opposites but companions. The very elements that can explode in a lab are the same ones that allow your nerves to fire gently, that regulate the beat of your heart, that flavor the food you eat. Volatile in one context, sustaining in another. Their story is a lesson in balance. The same properties that make them dangerous also make them essential. In this way, science reveals a truth that echoes in life itself, that even the most restless energies can f. As you drift, think of the alkali metals as sparks at the edge of sleep. They flare quickly, but they also illuminate. They remind us that beginnings are always powerful, always filled with energy. In the larger story of the periodic table, they are the first column, the fiery starting point from which everything else unfolds. And just as your day began with activity and now ends in calm, their story begins in reaction and ends here in rest. Let their energy fade into the background, like embers glowing s. With this gentle understanding, we leave the alkali metals behind, carrying with us the image of their sparks, their flames, their vital roles. They are the first family of the periodic table's main body, and from them, the story moves on to their neighbors, the alkaline earth metals, a calmer yet still radiant group, waiting to be discovered as your journey continues deeper into both science and sleep. The next family on our slow journey through the periodic table are the alkaline earth metals. They sit in the second column from the left, just beside the alkali metals, and they include beryllium, magnesium, calcium, strontium, barium, and radium. Compared to the fiery sparks of their neighbors, they are calmer, steadier, yet still capable of glowing brightly in their own ways. Each of these elements carries within it a story of strength, structure, and often a soft radiance that makes them memorable. Beryllium comes first. It is rare and difficult to find, a metal with a pale, gray appearance. Though not common, it is strong and lightweight, used in spacecraft and technology that must endure both heat and lightness. Its presence is quiet, almost hidden, but its strength is undeniable. Like many rare companions, it may be overlooked, yet its role is essential in the designs that push human exploration forward. In the calm flow of tonight's lecture, beryllium shines as a subtle reminder of quiet strength. Magnesium is next, and perhaps you know it best from its glow. When burned, magnesium produces an intense, white light, brighter than almost any other flame. In the 19th century, it was used in photography, lighting up entire rooms for a single photograph. Today, it still glows in fireworks, sparklers, and flares. But magnesium is not only about fire. It lives within you, in every cell, helping enzymes work, helping muscles contract, helping energy flow. Without magnesium, life could not continue. Then comes calcium, one of the most familiar elements in this group. It is in your bones and your teeth, giving them strength and resilience. It flows in your blood, allowing signals to pass, muscles to move, and the heart to beat. The chalk once used in classrooms, the limestone in mountains, the shells of sea creatures, all are made of calcium compounds. To think of calcium is to think of stability, of the enduring structures that hold life steady. As you rest, imagine your own bones as quiet architecture. Strontium follows, and here the glow becomes more colorful. Strontium salts produce a deep red flame, the rich crimson you see in fireworks and flares. This element connects earth to sky, appearing in minerals in the ground and then painting the night with fiery red light. Its beauty is immediate, striking against the dark. And yet, like the others, strontium also has quieter roles, strengthening materials, supporting research, and reminding us that beauty and function often coexist in the same form. Next comes barium, a heavier element, known for its striking green flames. When used in fireworks, barium creates brilliant green bursts across the night sky. In medicine, barium compounds are used in imaging, helping doctors see inside the human body. Though pure barium is reactive and must be handled with care, its compounds become tools of healing, guiding eyes into hidden places. Here again is contrast, an element that can react violently yet also reveals hidden truths in the quiet world of medicine. Finally, there is radium, once famous, now known for both its power and its danger. Discovered by Marie and Pierre Curie, radium glows faintly in the dark, releasing light from its own energy. At first it was celebrated, painted onto watch dials, used in tonics, thought to carry healing power. But over time, its dangers became clear, its radiation harmful to those who worked with it. Today, radium is a reminder that light can carry both beauty and risk, that not all glow is gentle. Its story is both or. Together, these alkaline earth metals form a family that balances energy with structure. They are less reactive than the alkali metals beside them, yet still lively enough to glow in flames, to shape life, to hold the bones of creatures and the minerals of the earth. Their name, alkaline earth, comes from their oxides, once thought of as earthy substances that formed basic solutions. They are the elements of the earth and the body, steady, reliable, glowing when called upon, quiet when at rest. In the placement of this family, in the second column of the periodic table, is meaningful. They each have 2 electrons in their outer shell, a pair that gives them more stability than the single electron of the alkali metals. They do not give up their electrons as quickly, and so they react more slowly, more deliberately. This is why they are calmer, less fiery, but still ready to shine. Their chemistry is steadier, their presence more enduring. They are not the sparks at the beginning of the story, but as you breathe gently, you may picture the colors they bring: the white blaze of magnesium, the red of strontium, the green of barium, the faint glow of radium. Imagine these colors as soft lights in the distance, fireworks slowed down until they shimmer quietly in the sky, never bursting loudly, only glowing steadily. Let their lights guide you deeper into rest, their patterns steady and calm. Their family stands together, glowing gently, reminding you that the universe contains both sparks and steady fluid. And so, as this section draws to a close, think of the alkaline earth metals as companions of strength and glow. They build the bones of life, they light the night sky with color, they show both safety and risk, beauty and stability. Their presence on the periodic table is a reminder that balance lies between extremes, between fire and stillness, between danger and life, between light and rest. With their story complete, we turn now toward the next family, those shining builders of history and technology. The heart. The heart of the periodic table is filled with a family of elements known as the transition metals. They stretch across the wide middle of the chart, forming the great body between the reactive families on the left and the quieter nonmetals on the right. These metals are the materials of civilization itself. They are the shining, strong, and versatile elements that humans have shaped into tools, weapons, coins, wires, and structures. Yet even though they are central to industry and technology, tonight, at the beginning of this long row is scandium, a soft entry point into the transition series. Then comes titanium, strong and light, used in aircraft and implants, a metal that endures without rusting, carrying both strength and grace. Vanadium follows, used in steels, giving them toughness, hidden inside alloys yet quietly supporting the strength of bridges and buildings. Chromium glimmers, known for its shine, coating metals to protect them, reflecting light in polished surfaces. These are the opening N. Manganese comes next, a quieter element but essential in small amounts for life, found in enzymes that allow your body to function. Iron follows, one of the most important elements in human history. For thousands of years, iron has been the backbone of tools and weapons, the heart of industry, the foundation of bridges, ships, and skyscrapers. In your body, iron carries oxygen in your blood, each hemoglobin molecule holding this metal at its core, allowing you to breathe, to think, to dream. Imagine your. After iron comes cobalt, a deep blue pigment in art, a hidden strength in alloys. Nickel follows, hard and resistant, used in coins, in steels, in magnets. Copper is next, warm and red in color, one of the first metals ever used by humans, shaping the dawn of technology. Imagine a piece of copper wire, carrying electricity silently across your home, or an ancient copper tool held in human hands thousands of years ago. Copper bridges past and present, gentle and enduring. Then comes zinc, protective and PR. The transition metals continue with silver, gleaming and precious, shining in jewelry and coins, but also carrying electrical signals with remarkable ease. Its beauty and utility make it both adornment and tool. Cadmium follows, with uses in pigments and batteries. Then comes gold, one of the most treasured elements, admired for its glow, valued across cultures as a symbol of wealth and permanence. Gold does not tarnish, it does not rust, it simply endures, gleaming steadily, as if time itself cannot tue. Further along, the transition metals include mercury, unique for its liquid state at room temperature, flowing like a silvery mirror. Though once used in thermometers and instruments, its dangers have made us more cautious, yet its presence remains a curiosity, a reminder that not all metals are solid and unchanging. Then comes a series of heavier metals, hafnium, tantalum, tungsten, rhenium, each with their own strengths, some with the highest melting points of any material known, able to withstand intense. Among them, platinum stands out, soft and silver, used in jewelry, in medicine, and in catalytic converters that clean the air from engines. It is rare, precious, and resistant to corrosion, often seen as a metal of prestige but also quietly protecting the environment. Beside it are palladium, rhodium, iridium, osmium, and ruthenium, the noble transition metals, rare and valuable, used in technology, in fine instruments, in jewels. Their names may sound distant, but their presence touches daily life in Sioux. Together, the transition metals show an extraordinary range of properties. Some are strong and unyielding, others soft and malleable. Some gleam brightly, others remain hidden in alloys. Some are essential to life, like iron and zinc, while others are toxic if misused, like cadmium and mercury. They form the backbone of construction, the sparkle of ornaments, the currents of electricity, and the invisible processes of enzymes. They are the builders, the shapers, the workers of the periodic table, and with. The chemistry of transition metals is rich. They can form multiple oxidation states, allowing them to create colorful compounds, vivid reds, blues, greens, and yellows. In crystals, their ions bring color to gemstones, giving emeralds their green, sapphires their blue, rubies their red. The world of minerals and jewels owes much of its beauty to these metals. Imagine holding a gem, light passing through it, the color vibrant and deep. That color is the quiet gift of transition metals, unseen yet powerful. Culturally, these metals have guided human progress. The Bronze Age, a time when copper was mixed with tin, gave rise to tools stronger than stone. The Iron Age followed, transforming societies with new weapons and new structures. Gold and silver became the standards of currency, shaping economies and empires. Platinum, palladium, and their siblings became symbols of rarity and purity. The history of humanity is written not only in books but also in metals, in the tools held by hands, in the coins exchanged. In your own body, transition metals play roles both large and small. Iron, as we've said, carries oxygen. Zinc helps enzymes work, supports the immune system, and aids in healing. Copper assists in forming blood vessels and maintaining nerves. Even in traces, these metals support life. Without them, the body would falter. And so, while they build bridges and towers outside, they also quietly build life within, balancing the physical world with the biological, strong in structure, gentle in function. As you rest, imagine the transition metals as a great orchestra section, filling the middle of the symphony with rich, deep notes. The alkali metals and alkaline earth metals are like the opening chords, bright and striking, while the noble gases at the end are like the closing silence. But the transition metals are the steady music in the middle, carrying the melody, providing harmony and strength. They shine, they endure, they support. Their presence is broad and central, just as their position on the T. Picture iron beams rising in a skyscraper, shining steel bridges stretching across rivers, golden jewelry glowing in firelight, silver coins passing through hands, copper wires carrying power invisibly through walls. These are the gifts of the transition metals, woven into daily life so completely that they are often unseen, unnoticed. Yet they are everywhere, surrounding you, supporting you, enabling the world around you. Tonight, as you breathe and drift, their strength becomes a metaphor for your own awe. In the grand design of the periodic table, the transition metals are a reminder of balance between beauty and utility, between the delicate and the strong. They are proof that science and life are not separate but connected. From the red of a ruby to the steel of a bridge, from the blood in your veins to the circuits in your home, these metals form a foundation as constant as your own heartbeat. To know them is to recognize the quiet strength of matter, shining and strong, enduring and gentle. And as beneath the main body of the periodic table, often shown as two separate rows resting quietly below, lie the lanthanides and actinides. At first glance, they may appear as an afterthought, a footnote to the grand design of the table. But their placement is intentional, and their stories are remarkable. These are the hidden realms of the periodic chart, elements that are rare, complex, and filled with mystery. Though not as widely known as gold or iron, they are essential to technology, energy, and even th. The lanthanides are the first of these two rows. They begin with lanthanum, from which the series takes its name, and continue through cerium, neodymium, europium, and others, ending with lutetium. These elements are often called the rare earths, though in truth, some are more common than their name suggests. Their rarity lies not in absence but in difficulty. They are hard to separate, often bound tightly in minerals, hidden together in the crust of the earth. To extract them requires patience, precision. Lanthanum, the first of the series, is a silvery metal used in lenses, making glass clearer and sharper. Cerium, the next, ignites easily and is used in lighter flints, a spark struck again and again without fail. Neodymium is one of the most famous, forming magnets so powerful that they can lift weights far greater than their size. These magnets drive motors, headphones, and countless devices of modern life. Europium gives red color to screens, terbium adds green, and together they paint the lights of tea. The lanthanides are sometimes described as quiet workers of the modern age. They hide inside smartphones, wind turbines, satellites, and electric cars. They are not metals of ancient legend like gold or silver, but they are the metals of the future, shaping the technology of today and tomorrow. Without them, the colors of screens would fade, the strength of magnets would weaken, and many of the conveniences of modern life would vanish. Their presence is subtle, often unseen, but their importance is vast. Chemically, the lanthanides resemble one another so closely that separating them is a delicate task. They all prefer to give away 3 electrons, forming similar compounds, glowing in flames, and shining in lights. Because of their similarity, they were long considered confusing, a cluster of elements difficult to tell apart. Yet once again, patience revealed order, and their row was placed carefully beneath the table, showing that even complexity carries a pattern. Their placement may look unusual, but beneath the lanthanides are the actinides, the second hidden row. These elements begin with actinium and stretch through thorium, protactinium, uranium, and beyond, all the way to lawrencium. Unlike the lanthanides, whose glow is mostly gentle, the actinides are known for their immense energy. Many of them are radioactive, their atoms unstable, releasing particles and energy as they decay. This property makes them both powerful and dangerous, gifts and risks bound together in the same form. Their presence. Thorium was once considered a possible fuel for reactors, a steady source of power. Uranium, one of the most famous, has shaped the world profoundly. In reactors, uranium fuels electricity for cities. In weapons, it has brought destruction. It is both the promise of power and the reminder of caution. Plutonium, another actinide, carries the same dual role, energy and risk, creation and devastation. The actinides are elements of extremes, offering immense potential while demanding respect. Their story is on. Yet beyond their association with power, the actinides also play quieter roles. Americium is found in smoke detectors, keeping homes safe with silent vigilance. Curium, named for the Curie family, honors the pioneers who first revealed the secrets of radioactivity. Californium, Einsteinium, fermium, many of these elements are synthetic, created in laboratories, existing only in small amounts for short times. Their presence proves that the periodic table is not closed, that human curiosity continues to expand. Together, the lanthanides and actinides remind us that what lies beneath the surface often carries great meaning. They are placed apart to keep the table's shape balanced, but they are not lesser. They are hidden chapters, adding depth to the story. The lanthanides bring light, color, and magnets, weaving themselves into daily life invisibly. The actinides bring energy, power, and caution, shaping the course of history and technology. Both series are bridges between the known and the unknown, the present. To picture them, imagine two quiet rivers flowing beneath the main stream of the table. The first river, the lanthanides, glows faintly with color, carrying sparks of light and magnetism. The second river, the actinides, runs hotter, with energy coursing through it, sometimes peaceful, sometimes overwhelming. They flow parallel, unseen by many, yet they nourish the larger landscape. They are the hidden threads in the tapestry, essential though not always noticed. As you drift deeper into calm, you may see. In the rhythm of the periodic table, these two series are like hidden verses in a long poem. You could skip them and still see the shape of the whole, but if you read carefully, their verses add richness and depth. They remind us that even in the quiet corners of science, meaning abounds. The lanthanides and actinides may not shine in everyday speech, but their presence glows in every screen, hums in every magnet, and powers the energy of nations. To learn of them is to uncover secrets, to glimpse the power. As you let this knowledge settle, allow yourself to rest in the thought that the universe holds both the obvious and the hidden, the familiar and the mysterious. The periodic table does not hide them to diminish them but to give them a place that maintains balance. In the same way, your own mind holds both clear thoughts and quiet mysteries. Both are part of the whole, both give depth to who you are. And so, with a calm heart, we leave the hidden rows behind, carrying their quiet glow with us as we move. Among the many families of the periodic table, the nonmetals stand apart for their quiet but essential role. They are not shiny like the metals, not heavy in hand, not builders of bridges or coins, yet they form the very fabric of life. Without them, the earth would be silent, lifeless stone. With them, the air is breathable, water flows, plants grow, and bodies live. These elements, oxygen, carbon, nitrogen, phosphorus, sulfur, hydrogen, and others, may seem modest in their appearance, but their presence begin with carbon, the great architect of life. Carbon atoms link together in chains, rings, and branching structures, forming the backbone of every living cell. From diamonds glittering deep in the earth to graphite soft in pencils, carbon shows many faces. In living systems, it builds proteins, fats, sugars, and DNA, weaving the molecules of life with patient precision. Imagine carbon as a quiet builder, never flashy, but endlessly versatile, shaping forms as simple as a grain of sugar or as complex as. Next is nitrogen, silent and invisible, yet it makes up most of the air around you. For out of every 5 breaths you take are nitrogen, though your body does not use it directly. Instead, nitrogen becomes part of proteins and genetic material, essential for growth, repair, and memory. In the soil, nitrogen nourishes plants. In your body, it builds tissues. Lightning splits nitrogen molecules in the sky, rain carries them into the ground, and life continues. Though unseen, nitrogen is always present, key. Oxygen, perhaps the most familiar of all, is the breath of life. Every inhale fills your lungs with oxygen molecules, each one carried by iron in your blood, traveling to every cell. There, oxygen participates in the quiet chemistry of energy, allowing your body to live, to move, to rest. Without oxygen, the world would be silent. Fires would not burn, animals could not breathe, water itself would not exist, for water is a union of hydrogen and oxygen, a simple molecule that is also the foundation of seas. Phosphorus, though less famous, glows in the dark when exposed to air, earning its name from the Greek word for light bearer. In your body, phosphorus is part of DNA, the spiral code of life, and of ATP, the molecule that carries energy to every living process. Without phosphorus, energy would have no messenger, and life would falter. Sulfur, too, plays its role. Known since ancient times for its sharp smell, sulfur is found in proteins, shaping their structure, and in volcanoes, shaping the earth. Hydrogen belongs here as well, already known to us from the beginning, the simplest element, yet essential in water and inorganic compounds. Combined with carbon, nitrogen, and oxygen, it helps form the molecules of life. With these elements together, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, you have the core ingredients of biology. They are sometimes remembered with the simple acronym CHNOPS, a gentle way of naming the alphabet of life. From these few letters, all living words are writ. The nonmetals extend beyond the elements of life. Fluorine, chlorine, bromine, and iodine, the halogens, bring reactivity and strength to compounds, disinfecting, healing, or glowing in lamps. Selenium captures light in cells, helping the body manage energy. Even noble gases like neon and argon, though unreactive, belong within the greater family of nonmetals, offering light, safety, and calm stability. Each of these elements may seem small, but each has its place, each carries meaning. Together they show. In the periodic table, the nonmetals cluster on the right-hand side, opposite the metallic world of the left and center. This placement reflects their contrasting nature. Metals give electrons easily, shining, conducting, forming structures. Nonmetals take or share electrons, forming molecules, building life. Metals are strong and visible, nonmetals are light and often invisible. And yet both are necessary. Without metals, we would have no tools, no wires, no cities. Without nonmetals, we would have no brother. Their chemistry is subtle but vital. Carbon forms 4 bonds, linking endlessly in flexible patterns. Oxygen forms 2, balancing strength and simplicity. Nitrogen forms 3, anchoring itself with stability. Phosphorus and sulfur shift their bonds as needed, adapting, shaping molecules. Together, they create not rigidity but adaptability, a chemistry suited for life. In contrast to the strength of metals, the nonmetals bring flexibility, variety, and softness. In their quiet presence, complexity emerges. Think of the contrast between stone and breath. Stone is heavy, metallic, solid. Breath is invisible, light, flowing. The nonmetals are the elements of breath, of fluidity, of change. They do not gleam in the sunlight but they shimmer in water, in air, in firelight. They live in the spaces between, filling emptiness with substance. As you lie here, breathing quietly, the nonmetals are entering and leaving your body with every inhale and exhale, sustaining you without sound, without effort. Their role is A. Historically, nonmetals puzzled early scientists. They did not behave like metals, they were difficult to place. Oxygen, discovered in the 18th century, revealed itself as the true element of fire, not phlogiston as once believed. Nitrogen, identified as the missing portion of air, showed that the atmosphere was not a single substance but a mixture. Carbon, long known as charcoal and diamond, became recognized as the foundation of chemistry. These revelations reshaped science, showing that the invis. Today, we understand that life itself is chemistry of nonmetals. Every heartbeat, every dream, every breath is guided by their quiet presence. You are carbon and water, oxygen and nitrogen, phosphorus and sulfur. These are not distant abstractions but intimate truths. They are within you, they are you. When you eat food, you are gathering carbon compounds built by plants from sunlight, water, and air. When you breathe out, you return carbon dioxide to the atmosphere, continuing a cycle billions of years. In the greater design of the table, the nonmetals remind us that strength is not always loud, that importance is not always obvious. Metals may dominate the eye with their shine, but nonmetals dominate life with their subtlety. They are the whisper of chemistry, the breath of the universe, the quiet scaffolding of existence. Their presence assures us that even the lightest, softest, and most invisible parts of the world hold immense power. As you rest deeper now, picture the nonmetals as a gentle circle surrounding you, carbon weaving your structure, oxygen filling your lungs, nitrogen flowing around you, phosphorus carrying energy, sulfur shaping proteins, hydrogen binding water. They are the quiet companions of life, the unseen foundation. And as you drift further into calm, know that they will continue their silent work, steady, reliable, patient, just as they have for billions of years. On the far right side of the periodic table, just before the noble gases, lies a family of elements called the halogens. Their name means salt formers, for they readily combine with metals to create salts. Fluorine, chlorine, bromine, iodine, and astatine make up this family, and though they are dangerous in their pure forms, they are also deeply woven into the fabric of life and daily existence. The halogens are a family of contrasts, poisonous and healing, corrosive and protective, unsettling in eyesore. Fluorine stands first, the lightest and most reactive of them all. It is a pale yellow gas, so eager to react that it will attack glass, water, and nearly anything it touches. Alone, it is fiercely dangerous. Yet in compounds, fluorine is gentle and useful. It strengthens teeth when added to water in small amounts. It forms part of fluorides in toothpaste, protecting enamel from decay. It helps create materials like Teflon, which make cookware non-stick. Fluorine reminds us that even the most aggressive L. Next is chlorine, a greenish-yellow gas with a sharp, pungent odor. In its pure form, it can irritate lungs, eyes, and skin, a reminder of its dangerous side. But combined with sodium, it forms ordinary table salt, one of the most essential compounds in human life. Salt seasons food, preserves it, and has carried cultural and economic significance for thousands of years. Chlorine is also used in disinfectants and in swimming pools, killing harmful bacteria and keeping water safe. Once again, contrast gid. Bromine follows, a deep red liquid at room temperature, unique among the halogens for this state. Its vapor is irritating, and care must be taken to handle it. Yet bromine compounds find use in flame retardants, photography, and medicine. It is both unsettling and protective, its presence demanding respect but offering benefits when guided by human knowledge. Like a restless tide, bromine drifts between danger and utility, a reminder that elements are neither good nor bad, only powerful in their nature. Then comes iodine, darker and gentler compared to its siblings. Iodine crystals shine with a metallic luster, and when heated, they turn into a violet vapor, glowing softly in the air. In the body, iodine is essential. Your thyroid gland uses it to create hormones that regulate growth, metabolism, and energy. Without iodine, the body falters, but with it, balance is restored. Iodine is applied as an antiseptic, painted on skin to protect wounds. It stands as a symbol of healing, showing that within this. Finally, At the bottom of the group is astatine, the rarest of all halogens. It is radioactive and unstable, existing only in traces for brief moments. Few have ever seen it directly, and yet it completes the family. Its fleeting presence reminds us that the periodic table contains not only the familiar but also the mysterious, the elements we can use daily and the elements that slip away almost as soon as they are formed. Astatine is a shadow at the edge of knowledge, a reminder of how much there is St. Together, the halogens are bound by their chemistry. Each one has 7 electrons in its outer shell, always seeking just one more to become complete. This longing makes them reactive, eager to combine with metals to form stable salts. Sodium meets chlorine, potassium meets iodine, calcium meets fluorine, and in each union, stability is achieved. Alone, the halogens are dangerous, restless, unsettling. In combination, they become essential, forming compounds that sustain life and protect it. Their family. The contrast of their roles cannot be overstated. They are toxic gases and healing medicines. They are corrosive alone and nurturing in partnership. They burn, yet they protect. They unsettle, yet they stabilize. This duality makes them one of the most fascinating families on the periodic table. In their presence, we are reminded that nature often carries opposites within the same hand, that danger and safety, poison and cure, can emerge from the same source. Picture the halogens not as threats but as glowing lights in the distance, each one with a different color. Pale yellow fluorine, greenish chlorine, red bromine, violet iodine, shadowy astatine. Imagine them as lanterns along a path, each burning brightly, each with its own tone. They flicker and shift, but together they guide the way, showing that even unsettling elements can create beauty when seen in the right light. Their glow does not need to frighten, it can soothe, reminding you that contrast is power. As you breathe gently now, remember that the air around you contains traces of these halogens in safe forms, that your body depends on them, that your daily life is touched by their presence. They are not distant abstractions, they are close companions, powerful but manageable, vital yet calming. The halogens stand near the edge of the table, reminding us that even the most reactive forces can find balance, and even the most dangerous energies can serve life when understood. And so, as this section ends, think of the halogens as guardians at the edge, sometimes fierce, sometimes gentle, but always significant. They embody the balance between danger and healing, between destruction and protection. Their story is one of transformation, of volatility finding peace through partnership. Let their contrasts lull you into rest, for even in their restless chemistry there lies a quiet truth: everything has its place, and in its place, everything can become part of harmony. At the far edge of the periodic table, resting in the last column, is a family of elements unlike any other. These are the noble gases: helium, neon, argon, krypton, xenon, and radon. They stand apart not because of noise or reaction, but because of their quietness, their calm refusal to join in the restless dance of chemistry. Where other elements bond, break apart, and form compounds in ceaseless activity, the noble gases remain still. Their outer shells of electrons are complete, full, satisfied. They begin with helium, already known to us from the earliest chapters of the universe. Light and lifting, helium floats away from Earth's grasp, drifting into the sky, never to return. It does not burn, it does not corrode, it does not react, it simply exists, content in its stability. In stars, helium is abundant, a product of fusion, glowing quietly in the fabric of the cosmos. On Earth, we see it in balloons, in blimps, in cooling systems that demand the coldest temperatures. Helium is a whisper of the uni. Neon follows, glowing with a soft crimson-orange light when electricity passes through it. You have seen neon signs glowing against the night, letters and shapes painted in gentle fire. Though its presence in Earth's atmosphere is faint, its glow is unmistakable. It does not combine into compounds, it simply shines when coaxed. Neon represents quiet beauty, a light that does not burn but illuminates, steady and calm. Imagine a city street at night, its neon signs glowing like lanterns, soft against the Argon is next, invisible yet abundant, making up about 1% of the air around you. Every breath you take carries argon atoms, slipping in and out of your lungs without reaction, without sound. Argon shields welders' flames, creates stable environments for scientific experiments, and fills light bulbs to protect filaments. Its presence is subtle, unnoticed, yet always there, reminding us that even silence has a role, that even the invisible can hold meaning. In your breathing tonight, argon is flowy. Then comes krypton, a noble gas that glows with a pale white-blue light when energized. Its name means the hidden one, and indeed it is rare in the atmosphere, hidden in small amounts. Yet when revealed, it glows with elegance. Krypton is used in specialized lights, in flashes that capture photographs, in lasers that measure distances with great precision. From hiding, it offers clarity. Imagine a hidden lantern, uncovered just long enough to illuminate a path. That is krypton's presence, quiet, rare, and xenon follows, heavier and mysterious. When excited, it produces a bright blue glow, used in headlights, projectors, and medical imaging. Though heavier than air, it moves gently, rare and precious. Xenon is used in anesthesia, calming patients into rest, carrying them safely through sleep. Its role in medicine makes it a fitting companion for our own journey tonight, reminding us that chemistry can soothe as well as excite. The blue glow of xenon is a calming flame, not for burning but for guiding, not F. Finally, there is radon, the heaviest of the noble gases, radioactive and fleeting. It seeps quietly from rocks and soil, invisible yet detectable, carrying both mystery and caution. Though dangerous in high amounts, it too is part of the natural world, part of the balance of the earth. Radon reminds us that even among the most peaceful family, there are shadows, and that even silence can carry power. It is the quiet end of the noble gases, a reminder that completion does not always mean permanence. What binds all these gases together is their refusal to react. Their outer shells of electrons are complete, giving them stability. While other elements seek partners, eager to give or take electrons, the noble gases remain still, content with what they are. This makes them unreactive, stable, almost aloof. But in that aloofness lies peace. They are the silent guardians of the table, showing that not all value lies in change, that sometimes strength is found in stillness. In the grand contrast of the periodic table, the noble gases balance the volatility of the alkali metals on the far left. The alkali metals are restless, flaring into fire at the touch of water, always eager to give away their lone electron. The noble gases are the opposite, complete and calm, unwilling to give or take anything. At one edge of the table, sparks, at the other, serenity. Together, they frame the story of elements, showing us that extremes exist in harmony, that the restless and the still ca. Picture them now as lanterns glowing softly in the darkness. Helium, pale and lifting. Neon, glowing red-orange. Argon, invisible but steady. Krypton, pale and hidden. Xenon, blue and calm. Radon, shadowy and fleeting. Imagine them lined up like quiet stars, each one steady in its place, each one contributing to the quiet glow of the night. They do not rush, they do not fight, they do not demand. They simply shine when invited, each in their own way. Their uses reflect this calm presence. Helium cools, neon lights, argon shields, krypton measures, xenon soothes, radon warns. They are guardians of safety, guides of light, companions of rest. Their chemistry may be minimal, but their gifts are profound. They remind us that sometimes less is more, that silence can carry depth, that presence alone can be powerful. Just as you rest without effort, they exist without striving. As you breathe now, think of them filling the spaces around you. Invisible, stable, patient. They do not change you, they do not demand from you, they simply accompany you, as silent guardians of the night. Let their quiet stability settle into you. Let helium's lightness lift you, neon's glow warm you, argon's presence steady you, krypton's hidden clarity guide you, xenon's calm soothe you, and radon's fleeting shadow remind you of balance. They are the noble gases, and their nobility is in their peace. And so, as we close this section, allow the noble gases to be not distant curiosities but companions in your rest. They are the elements of silence, of glow, of stillness. In their presence, the restless fades, the mind quiets, and the body sinks deeper into calm. They are the last column of the periodic table, the guardians at the edge, watching quietly, holding space for balance. With them, the table feels complete, the symphony of elements finds its soft closing chord, and you are ready to drift forth. As our long journey through the periodic table comes to an end, take a deep breath and let yourself rest in the quiet knowledge you have gathered. From hydrogen, the simplest element, to radon at the noble edge, we have moved slowly and gently across the chart of matter, following the rhythm of the universe itself. Each element has offered its story, its place, its meaning, and now the table as a whole rests in your mind like a completed picture. There is no rush to recall, no pressure to remember detail. Think back to where it began, with the origins of the elements in the vastness of space. Hydrogen and helium drifting after the Big Bang, gathering into stars, fusing, shining, and giving birth to heavier atoms. Remember the fire of supernovae scattering iron, gold, and uranium into the galaxy. Out of those cosmic events came the ingredients of planets, oceans, and life. You are made of those same atoms, each one ancient, each one carrying history within it. To know the table is to know yourself, to see. We moved from the beginnings of classification to the moment of Mendeleev's vision, when scattered discoveries were arranged into order. A chart of boxes and numbers, once confusing, became a guide, a map to all matter. The table is not only a scientific tool but also a symbol of clarity. Just as Mendeleev trusted the gaps in his table to be filled, so too you can trust the spaces in your own life to find meaning with time. The table reflects patience, and patience reflects peace. We explored the families one by one, from the reactive alkali metals to the calm noble gases, from the hidden lanthanides to the shining transition metals. Each family held its character, its colors, its uses, its contrasts. Some elements burst into flame, others refused to react at all. Some shaped mountains, others shaped blood. Some carried energy, others carried silence. Together, they formed balance, not chaos. And in their balance, we find reassurance that nature itself is harmonious. The nonmetals reminded us of life, of breath, of water and food, of the quiet bonds that sustain every living cell. The halogens reminded us that danger and healing can spring from the same source. The noble gases reminded us that sometimes the greatest strength is stillness. Every element became a teacher, every element a gentle voice. Listening to their stories has been less about memorization and more about recognition that the world around you and within you is built of these same bricks. The periodic table also reminded us of beauty, of patterns repeating, of symmetry that mirrors the rhythm of breath and heartbeat. In its structure, we saw poetry. In its families, we saw music. In its order, we saw calm. The table is not random, it is designed by the laws of nature, laws that are steady and true. And so, by reflecting on it tonight, you have reflected on the order of the universe itself. That order holds you even now, as you drift deeper into rest. This journey has not been a test of memory, nor a demand for attention. It has been a gentle river, carrying you through science with calm narration, allowing you to float where you will. Some details may have stayed, others may have faded, and both are fine. Learning does not need to be forceful, it can be as natural as breathing, as restful as dreaming. Even as you sleep, your mind continues to weave connections, to hold on to the rhythm of what it has heard. Tonight's lecture may become part of your day. As you breathe slowly, picture the table once more, glowing softly in the darkness of your mind. Rows stretch like horizons, columns rise like pillars, and each box glows with its own quiet light. You do not need to recall every number or every name. It is enough to know that order exists, that the universe is patterned, that you are part of this design. The table is whole, and you too are whole, resting now in its calm. Let yourself settle deeper into stillness. The day is behind you, the journey is complete, the knowledge is planted gently in your mind like seeds in soil. In time, those seeds may grow into understanding, or they may remain simply as comfort, knowing that even the smallest atoms have their place, and so do you. The periodic table is finished, and you are safe in its embrace. And so, with this reflection, we close the journey. From the fire of stars to the calm of noble gases, from the chaos of discovery to the order of the table, we have seen how science is not only knowledge but peace. Allow these final words to drift into silence. Allow yourself to rest fully. The periodic table, like the universe itself, continues on, patient and complete. You need only to sleep, to breathe, and to know that you are part of its quiet harmony.